Height, minimize. Cool. So, in linear algebra, what are the main topics that we need to understand? So, first couple of things are nothing but the equations, pure mathematical equations that we need to make cheat sheet. Maybe Prem will provide it. So, equation of a line,
Brother, don't
plane.
tell me anything. Not gonna provide anything.
Yes, or you can use this page also. It is always here, and this page is all about the equations only, right? So first few points are nothing about the equations of different geometric shapes, because like in any, you can say, a problem, machine learning problem that we have seen, we need to use either a plane or hyperplane or line. But it is also possible to use circle, ellipsoid, though we are not using it much, because by the time what are the classification or regression methods we have seen, mostly we are using either line, plane, quadratic equation, maybe generalized or hyperplanes, right? But as part of algebra we need to give like justice to everyone. So first couple of things, just the formulas we need to remember, and these are some important formula that we should know like by lifelong actually. So location of a data point, on which part of a data point it is. In classification, it is really useful, right? Distance from origin or distance from a plane, data point distance from hyperplane. So how far the point is from the hyperplane, it is also needed in support vector machine, linear logistic regression. In linear regression, also to calculate the errors, right? So this is like very much useful equations, and by this time you must be knowing it, right? Okay, and then we will see some vector algebra, how to measure the magnitude, the angle, some arithmetic operations, dot product, cross product. Cross product is not much used because we are not interested in the resulting direction of a force or something, output vector. And the angle between two vectors, it is also very much useful in case of cosine similarity in cos theta, like that thing, and projection of a vector. Correct. So let's have a bird eye view that I promised on some formulas. So the equation of a hyperplane is nothing but this w1 x1 w2 x2 wn xn plus w0. This is also called the bias term or intercept term, right? Is equal to 0. And why? And if you take just the 2D example, then we have this line, and this x1 x2 up to xn are nothing but your data point, or you can say features, right? Not data point, sorry, this is your features, right? And this x y z x y in case of 2D, or x y z in case of 3D, is also your dimensions, or you can say features, height and weight. Then it's just this thing. If you have three features, length, width, and height, then it is 3D. So the plane equation would be ax plus by plus cz plus d equal to 0. But we have seen like we can have 100 features, like, and only we have 26 alphabets in the abcd, right? So what we do, we just generalize everything in terms of w and x. So the equation of line in 2D in generalized form would be w1 x1 w2 x2 plus w0 equal to 0, right? If it is passing through origin, then this bias term, or you can say this thing, intercept term would be 0, correct? And this is the generalized formula for hyperplane. And by default, if they are not saying anything, then w and x, all the vectors are column vector. Column or row, it's column vector, right? By default, I might be mistaking here. Can anyone confirm? I guess it's column vector if nothing is given, right? So that's why we just take the transpose. So w is nothing but w1 w2 wn up to wn, and x is nothing but x1 x2 up to xn. And if you take the dot product between two, w and x, so it is nothing but w transpose x. So w1 x1 plus w2 x2 up to wn xn plus w0 equal to 0. So this is nothing but the equation form, you can say, is equal to 0, equality form, and this is the functional form. This is very useful, f of x equal to this. This form is very useful when you need to calculate the distance of a data point from a plane or hyperplane. Then we can remember the formula like that. Let's see that formula first. The equation distance from origin, sorry, data point distance from the hyperplane. So given any point p, we are given any point p. Let's say 3 to 1. Let's take more examples today. because in exams I see like they are like very much fan of this thing. Let's say we have this point p numericals, right? So and we have given the hyperplane pi can be represented as also three values. Why three values? Because for given hyperplane we just need to know the values of w, right? So w is also the normal vector. Given any hyperplane, the normal vector is w, and this w is nothing but w1 w2 w3 up to wn. So let's say we have hyperplane called 1 minus 1 3, and let's say it's passing through origin, so w0 bias term is nothing but 0. Now what happen is, this is 3D point. We have the hyperplane also w1, w2, w3. So how to calculate the distance between the hyperplane? Let's say the point P is here. How to calculate this distance? So it is saying, I guess in textbook the formula is like uh, the derivation is there, and at last we got what we got is, if it is A, B, and C, we get WA, WB, WC like that. So it is nothing but putting this values 3 to 1 inside the equation of hyperplane. So what is the equation of hyperplane? It is nothing but W1 x1, W2 x2, W3 x3. So W1 x1, so 1 into 3, 3. Then minus 1, 2. Minus 1 multiplied by 2 is minus 2. 3 multiplied by 1 is nothing but 3. Right? Divide by mode of W. Mode of W is nothing but under root 1 square, 1 square, 3 square. So 9 plus 2, 11. So it is root 11. Right? So this is the answer actually. Right? 3, 3, 6, 2. 4 divided by root 11 is the answer. So how you got, so this formula, this f of x is really useful actually. Let me remove everything. So the hyperplane or given hyperplane can be represented as the this equality equation also is equal to 0, or you can also represent as y equal to fx equal to this. And this is useful when you need to predict something, correct? Because I am like in confusion if they will use the terminology from the machine learning and ask questions on geometry, right? So this is nothing but the predicted value given w and input x, and bias term, this is the y or y predicted equal to f of x. Yeah, so this is what we are doing, correct, in almost all machine learning algorithm. Given the value of weight and input, this is how we are predicting the output, correct? Okay. And let's have some look on the formula of circle sphere, right? So the circle in a circle is nothing but in 2D, right? So in 2D we have just two, you can say, dimensions. So it is simple: x minus c1 square, y minus c2 square minus r square equal to 0, right? So x and y is nothing but your dimensions. C1 and c1 c2 is nothing but the center, and equal to 0. Or in a generalized form, yeah, instead of x and y, you can use x1, x2. So x1 minus c1 square, x2 minus c2 square equal to r square, or minus r square equal to 0. I prefer this way because I can directly write f of x equal to this. Correct? At sphere, we just have one more dimension z, or x3, you can say in generalized form. So hypersphere is nothing but if you have dimension more than 3, then it is called the hypersphere. We cannot imagine it, but the equation is this, right? So x1 x2 up to xn in n dimension, the hypersphere equation is this, and the center is nothing but c1 c2 c3 up to cn, correct? And guys, if you have any doubt like it at any equation, just feel free to pause me because I'm going like too fast today, correct? Okay. I don't think like this is needed, but let's see one time. So ellipse with the center c1 c2 and axis, this is also called the major axis, this is called the minor axis, right? Any axis you can take interchangeably because we have this positive sign here, but mostly like in ellipse, the first axis we take is the major axis, second axis is the minor axis. So what major and minor axis is, if this is the ellipse, then this is called, this distance is 2a, the whole distance. So if you think in terms of radius in circle, it is a, but here it is b, this much is, so this much distance is 2b. So major and minor axis, this is major, this is minor. So if you have this axis, major axis with 2a and minor axis is 2b, then the ellipse formula is defined like this: x minus c1 square, y minus c2 square, same as circle. Just divide each dimension. So this is c, this is c1 c2, this is x axis, this is y axis, right? So if you are taking x minus c1, this is x, this is y, then you need to divide by the corresponding axis. So this is 2a, right? Because see, the intuition would be really useful if we are just given the distance, like this is 20, this is 10, then you need to take the 10 square here in x axis, because c1 is from x, c2 is from y, right? So by a square by b square. And if we generalize the formula, then we get at hyper ellipsoid would be x1 minus c1 square, x2 minus c2 square, up to nth dimension xn minus cn square, and we will divide the corresponding axis, right? And here like we don't have like major or minor, but this is the axis, the distance what you have in the direction in ellipse. That's so a1 square, a2 square, up to an square. Correct. And see, it's 60 mark question, 60 mark exam, right? So we can expect like one question from each topic, basically, right? Because we have like a less number of topic and a more number of questions. So we should cover everything basically for this exam. Okay. And rectangles, cubes, and cuboids, I have also skipped it because these equations are not even in our syllabus also, right? So this is the hyperplane. Okay, now here the actually the fun begins, and most you can say important part will start. So location of a data point, which is really useful, right? Given a hyperplane, how can you define, like, if given point p is on the positive half or negative half? And I assume, like, you know about positive negative half. Let's say this is origin, right? This is origin, and this is the normal vector w. Then in the direction of w, this side is defined at the positive half of a hyperplane, right? This is hyperplane pi, and this is in the like reverse direction, opposite direction of the w is nothing but the normal vector, right? Because it is nothing but the making the 90-degree angle. So this is the negative half, right? And we know, like, if there is a point, let's say here, let me take another color. Let's say we have point p on the hyperplane, then we know, like, it would be zero, equation of hyperplane. So f of p is nothing but the equation of hyperplane, which is w1 x1, w2 x2, w3 x2 up to wn xn, right? And plus w0 equal to 0, right? W0, don't forget about the bias term, like me. So, in this equation of a hyperplane, if you put the coordinates of p can be as simple as this: 3, 2, 1, right? Any coordinates which we are given. If you put 3 here, x1 equal to 3, x2 equal to 2, 1, and if you get 0, that means the point is on the hyperplane, right? And just a second. Yes, and after solving this equation for point p, if you get the positive value, that means it is on the positive half. So all these point would have the positive value. And if you after solving the this equation for given point p, if you get the negative answer, that means it's on the negative half, right? Consider this as a area of point parade they are doing, right? So this is nothing but the on the hyperplane, if f of p equal to 0, on the positive half if f of p equal to greater than 0, negative half if it is less than 0, right? So in any dimension, right, every hyperplane will cut your space into two parts, positive and negative half, correct? Okay, let's take one more important equation: distance from the origin. Let me clear this.
Mayur,
Yes.
in earlier the W will be in that direction only. Can it be in the opposite direction also in any other cases?
See this positive. See in this
Direction of
hyperplane we have
W
these two
vector.
direction, right? This
Yeah.
direction and this direction. So this
Yes.
positive direction is always in the direction of W. That's what I mean,
Okay. Okay.
right? So this plane is like dividing the space into two halves. So, and if I'm talking about this half, then it is positive half if it is in the direction of w. W is also in this direction and positive half is also in the same direction, right? So the positive half and the direction of W would be in the same in the same direction, this positive half and W, correct?
Will the W will be in the other direction? It is here this direction, right?
This
Can
is
it be
negative, yes, this is negative, the other
direction of
direction.
W?
Huh.
Okay.
So the W would be given, right? W1, W2, W3, like that,
Okay.
correct? Okay, let me take the next thing. Distance from origin, we already discussed this. So given point P, what we need to do is just solve. Oh, sorry, this is distance from origin. Pardon me. So distance from origin is nothing about. Let's say we have this hyperplane pi, and let's take origin somewhere here, right? It is not hard and fast rule that we should have always origin here. So the distance from the origin is nothing but the perpendicular distance or the shortest distance of a hyperplane, right? If they ask for the shortest distance or the perpendicular distance from the origin, it's all the same, right? So this perpendicular distance from the origin D is defined as W0 divided by mode of W. So this is the second mode of, you can say, second norm of a W, because it is nothing but under root W1 square W2 square up to Wn square. The second norm of W, that L2 we use, right? So this is second norm, right? I have just put one this, you can say, pipe here, but it is also like this, mode W. So this is nothing but the second norm. And whenever we have this kind of you can say, representation, it is nothing but under root W1 square W2 square up to Wn square, right? So the distance from origin is W0 divided by norm of W, right? It is also called norm of W. And data point distance, let's say we have this kind of a plane and we have any random point here. Let's say there is a random point here, there is a random point here, P or Q or anything. So we know the coordinate of P and Q, right? It would be given. Distance from, yes, yes, yes. We are taking that only. So there can be like any point, right? P, Q, R, like that. And actually we don't need to learn this equation also. Let me prove that. So the just concentrate on this formula. This formula is nothing but f of p. That means we put the value of p, the coordinates, right? Let's say coordinate we have 1, 2, minus 3. So we put these coordinates into the equation of pi, right? Also q we could have like minus 3 to minus 20. We just put in the equation of pi divided by mode w. What is the point, what is the coordinate of origin? It is 0, 0, 0. So if you put 0, 0, 0 in the equation of hyperplane, which is w1 x1 w2 x2 wn xn plus w0, so all the terms w1 w2 w3 would be 0, w1 multiplied by 0, w2 multiplied by 0, up to wn multiplied by 0, plus w0. W0 we don't have any multiplication, so the only w0 will remain, divided by mode w we have like already. So from this equation we can get this equation directly, correct? Because the coordinates, if you put this point f of p for origin is nothing but w0. I guess the idea is clear, right, Ganesh?
Mohit, can you explain the equation again? I mean,
Yes, so this f of p is nothing but
Mayur,
yes.
can you take some live example to show this diagram?
Definitely, I would love to. Sure. So let's take a pi, or let's take 2D example basically, because we should not have any doubt here. So let's use my favorite tool. Okay, and there is a like boring derivation also. I don't want to go there. This derivation. So this is the derivation actually of a point, perpendicular distance of a point from a hyperplane. So this is the derivation, but I'm not going into that. Let's do it mathematically, more graphically. Sorry. Let's take any random line, right? Let's take this, correct? Or let me have. Oh, sorry. Okay. So this is the line that we have, or this equation is horrible. Okay, 2x plus 3y plus 4 equal to 0. So this is line. Array, what happened? 3y equal to 2x. What happened? 2 minus 3y equal to 4. So this is line we have, right? So here w is nothing but minus 4, correct? Why can't I have like this minus 4 equal to 0? Okay. So this is a hyperplane, 2D hyperplane, right? This is a line, right? W1 is 2, W2 is 3. So what is the norm here? Norm W, or you can say normal vector, norm of this hyperplane. It is nothing but 2 minus 3, correct? Any doubt here? And W0 is nothing but minus 4, correct? Now let's take points and try to calculate the distance, correct? So let's have some random point. Where is the point? Let's take one origin 1 point at origin, 1 point here, and 1 point, let's say, here. Now if you understand, if you observe, the w would be here, w is here, 2 minus 3, no? How to undo this? 2 minus 3, so 2 minus 3 would be here. So this is w, right? So in the direction of w, this would be positive half, definitely, and this would be negative half, because this half is in the direction of w, correct? 2 minus 3, correct? And this is the intercept, minus 4. Okay. And okay, now this is positive, this is negative half. Now I want to calculate this distance and this distance of b, and this distance from this, correct? So now how can we calculate that? So according to formula, let's calculate according to formula. Then we have measurement tool here, then we will try to use the measurement tool. So according to formula, what should be the, you can say, the distance of this point from, let's take this point, this is 2 6, right? This is 2 6. What would be the this thing, what would be the settings? Let just a second, name and value. So this is 2 6. So how to calculate the distance from this plane? It would be f of p. F of p is nothing but 2 6. I need to put into this equation. So 2 2 is 4 minus 6 3 ja 18. Let me do it in Gujarati, sorry. 2 4 18 minus 18 minus 14 minus 4 minus 18, it would be, correct? 4 and minus 3 minus 6 minus 18 minus 4. So it would be minus 18, right? F of p divided by norm of w. Norm of w is under root 2 square plus under root 3 square. 4 plus 9 16. So it would be 4 under root 2 square plus 3 square. 4 plus 9, it would be 13, sorry. So it would be root 13. So root 18 divided by root 13 is the distance from the line, correct? Perpendicular distance. Let's see if we get the right answer, right? So root minus 18 divided by root 13. So 18 divided by root 13. Array, yeah. How to do it? SQRT 4.99, right? And this is looking like a 4.99. Let's try to measure it. But you got the idea, right? How did we calculate this? We just put this equation, f of p is nothing but the value 2 and 6. I just put it as x equal to 2, y equal to 6, right? And whatever the answer we get, divided by mod of w. Any doubt here, guys, for this equation, f of p divided by mod w? Someone say yes. uh, okay, let's
Okay,
try to
Maya.
measure.
Maybe it is the same question
Yeah.
like that. The one that you are referring, gems of AI.
Gems of AI, yes.
Yeah, and while I'm trying to access this, I'm being forwarded for some Chrome extensions.
Chrome extensions.
Yeah.
It should not ask actually. I'm just using one math JX only, but nothing fancy. Try another browser maybe. It's also opening in mobile also. Let's try to measure the distance of B and this thing. So see, this is 4.99, right? What we got here, correct? Now what happened? Now comes the fun part. This is A. Like what is the coordinates of A? It is 0 0. If I put 0 0 in this equation, what will happen? Only W0 will remain. 2 multiplied by 0 0, 3 multiplied by 0 0. Only W0 will remain. So minus 4 divided by root 13. Any questions? Minus 4 divided by root 13 I will get. Because x is 0, y is 0. So this term would be 0, this
Uh,
term would be 0. That's why we have
Mani, we
this
have to
equation W0 divided by mod W.
yeah, you
Correct?
have to add the one for coefficient also, right?
Where? Here, no?
Under
Okay.
yeah, under root of 2 square plus 3 square plus 4 square, right?
No, 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 no. It's mod W. Not this intercept term. Just up to Wn square. Always say up to Wn square we have, not W0. It is only up to like Wn square only. If you have still doubt, we can just go to this thing, this derivation. Correct? Okay. Because this distance is calculated by taking the help of this normal vector. That's why we have only mod W, not W0. Correct, but I'm not going into equation. Just remember that in mode of W we don't consider the bias term, or you can say this thing, this term, what it is called, this W0 intercept term. Correct. And see, this is value is why we are, see, this is negative value, no? We have this minus 18 divided by root 13. So this is negative value, minus 4.99 actually. If you solve, like if you consider the direction, but if you take the absolute distance is 4.99. And if we put 4 and minus 2 here, the value would be positive. So 4 to the 8, 8 plus 14 minus 4, right? So 14 minus 4, 10. 10 divided by root 13 we will have. Correct? Any questions, guys? I guess the idea is clear, right?
Just wanted to confirm, Mayur, if
Uh-huh.
this line was in the if this line was in second quadrant of this graph,
Huh.
shifted to that, so then the direction of W would be on the other side, right?
Yes,
Because
definitely.
it's yeah,
Yes.
because it's measured from origin only.
Correct. Correct.
Yeah, I just wanted to.
Correct.
Thanks.
No problem. Definitely we can have line like this. Then the W would be here. Minus 2, minus 3. See, W is nothing but minus 2, minus 3. Where the minus 2 and
Yeah.
minus 3 is? Here, right? Somewhere here. Minus 2, minus 3. Correct? And see, there is one more tool here. Perpendicular line. So if I take this, so this is perpendicular line. Let's see what is the equation of this perpendicular line. Y equal to 1.5x. So if you put minus 2 here, minus 2 multiplied by 1.5, minus 2 minus 3. So this is minus 2 minus 3. Correct? So this is W basically. Right? Okay.
Mayur,
Uh,
W always passing through origin perpendicular to plane, right?
yes. W is defined like that. From origin, you need to draw the this thing perpendicular vector.
Okay.
It would be always perpendicular. Minus 2 minus 3 we know this is coordinate here, this is minus 2 minus 3, but if you take this W, it would be always perpendicular to your hyperplane. Why? That's why it is called norm of W, or
Oh,
norm of, you can say, hyperplane. It's just a
so
terminology. Why it's called norm, I
Mayur,
don't know. Hmm?
Mayur, I have one question. So, how does a unit vector W comes into picture, and why does it come? I am not
Unit
able to
vector.
differentiate the concept between yeah W as a unit vector.
No. W. Why we are taking W as a unit vector? Oh, okay. Are
It's
we?
just to for the direction, right? We have to define the direction, so that's why we are taking that one.
No, no. I
The
guess
unit
he's
vector.
talking about in LSH. We normalize everything, right, for the two unit vector.
Yes, like in machine learning, we like in most of the cases we
Huh.
thought like the unit vector, correct? So
Huh. Correct. But
so I'm
is
coming from
W?
that point.
Mhm. So what happen if we apply normalization here, or we try to convert this into unit vector? I guess. See, in that we need to calculate the distance from 2 points, two different points. Correct. I guess the idea is somewhere there, but I'm not able to collect it because the unit vector would be nothing but we need to divide this equation by mode of w, right? Then this would be unit vector. But I don't know like how it is useful geometrically. I don't have answer right now. I need to do a bit brainstorming with GeoGebra.
Mayur Chiranjeev here.
Sure.
Okay. Normally, we use unit vector to represent direction. That is what I
Mm-hmm.
understand. So normally, whenever you don't need the magnitude of that, you just need the direction. You just mention the you
Hmm.
go ahead with the unit vector. So that will
Correct,
give you
correct.
the direction. That one. So
Correct,
so
correct.
for cases where you don't need the magnitude of that, you have to need you but you need to know the direction of that plane. So you mention with a unit vector.
Correct. And see, the benefit we got by taking the unit vector is trivial. If we take the unit vector w and w2, norm of w and w2 would be 1, right? So the cos theta would be just w1 dot product cos w2, right? So this is the main idea why we are taking unit vector, because it would be really easy and we just care about this theta only, right? We don't care about the magnitude of w. So if we take unit vector, this term would be 1, this term would be 1, so you just need to take the dot product and you know the theta, right? But geometrically how this unit vector w will help, I don't know, but yes, it would be really great, right? Because we just take the dot product multiplication of like d terms, and we know like cos theta, just take cos inverse and you know the theta term. Correct. So that's the, you can say, this thing advantage we have by taking the like unit vector, performing that standardization, right? When we derive, I guess that Euclidean distance is coming. Yes, maybe. Okay, but I don't want to spend much time now here. Let's jump on to vector algebra and this thing, assignment. If we take more time, we will take like 5 or 10 minutes break, and then we will jump onto calculus because it's also heavy thing. Okay. The vector algebra. So the vector representation, if nothing is given, this is machine learning terminology, right? This is not physical terminology anything, and the difference between physics terminology in this machine learning terminology is we always represent the vector which is originate from origin. So one end, or you can say a tail of a vector is always a origin. In physics you can have like any vector in the space. The origin can be anything, head can be anything, and tail can be anything, right? But in machine learning it would be like it would be originating from the origin only, right? So and it's by default it's column vector if nothing is given, right? So x1 x2 up to xn, this is n dimensional vector, and magnitude of p is nothing but norm of, sorry, this distance, this Euclidean distance, you can say, of p is this under root x1 square plus x2 square up to xn square. And this is real easy, right? Because it is originating from origin. So origin is always 0, so x1 minus 0, x2 minus 0, xn minus 0. So you can say this like this is a Euclidean distance from the origin only. Correct. And we have some arithmetic operations. This is boring. Plus minus, we just need to take the summation, or you can say subtraction, pairwise, x11 x21 x12 x22 like that. And this is interesting, dot product, right? Because this dot product is real easy. See, what we are doing is we are just taking the multiplication side by side. First dimension take multiplication plus, second dimension take multiplication plus, up to n dimension, and this would be equal to norm mod of x1 mod of x2 multiplied by cos theta. So this is really nice, you can say, relationship between this angular, you can say, representation x1 x2 cos theta, and this is a pure mathematic, or you can say arithmetic, just a multiplication and summation, and you will get this. And this is really useful by while calculating the angle between two, you can say, vectors. So if we are asked to calculate the angle, then we have just one tool that can help us, and it is dot product. Just take the dot product by multiplying the corresponding terms and equate it with equal to this thing, x1 x2 cos theta, right? By and we just need to take the cos inverse, and you know the theta, correct? And this cross product, and see, dot product is a scalar entity, correct? We are just taking the multiplication summation, so this is scalar. The answer of x1 dot x2, or dot product between two vectors, is always scalar. And if you take the cross product, then it is defined as mod x1 mod x2, like similar as dot product. Cos theta, we have here sin theta, and we have this unit vector n vector. This unit vector is defined as is in the direction perpendicular to x1 and x2, right? This is not useful. This is useful in physics in some context, when you need to calculate the magnetic force direction, like that. But this is not useful. If x1 and x2 is here, the resultant, this unit vector, would be the perpendicular to both, like this, correct? This is not very useful, like in machine learning we use this dot product much. Vectors and scalar is just a number, your real value number is scalar, and vector is this, you can say, n dimensional point, right? N dimensional point is nothing but the vector, correct? How can we check the variable is vector or scalar? I guess I answered this, right? So if the value is 2, 3, 4, 6, 7, like this, minus 3, minus 4, is scalar. Correct. I guess we have just one topic left, and then we will jump onto assignment. It is 12, 10, 12 already. Huh. And the projection of a vector, I don't know why I don't have it here. I will try to edit. Projection of a vector, because, yes. Huh. Here, in the projection of vector, we have two things, and I guess just one was covered. The projection of a vector is nothing but also vector. So we have the vector form and we have scalar form. We have two forms for the projection, and how the projection is defined is, let's say we have one. Let me change the color here. Let's say we have one vector uh, like this, any vector. Let's say A, and we want to project vector B on it. So we are projecting this on this. So this is the projection of B over A. So it is written like this: projection of B over A, right? So it is written like this. And and see, and always remember, this projection would be always in direction of A. So the direction is represented by the unit vector. And how we get the unit vector? Unit vector is very simple. Just take the vector A and divide by its magnitude. So it is nothing but the unit vector. Simple. And we just need to multiply this thing, this vector. So what is this vector? So this is nothing but, if I say this vector is, let's say, M for a moment. So M is, and always use this kind of a funny, you can say, if you can use W, X, Y, Z, or P, Q, R, S, anything, use that, because by using the same, you can say, this terminology, it's a very much chance that you will forget, right? So use the this kind of a funny terminology, right? So if I say this is M is nothing but B cos theta. So I just need to multiply it by B cos theta, right? I don't have space here, so I'm writing c theta. So this is the same equation like this. We are projecting x1 on x2, right? So we are projecting on x2, right? So we need to take the unit direction of x2. So the unit direction of x2 is nothing but x2 divided by mod of x2, and we need to multiply this by this distance m. So it is nothing but our first vector whom we are projecting. It is nothing but x1 cos theta. But this formula has one problem. we first need to calculate cos theta, right? By taking dot product and taking the cos inverse and everything. And in exam we don't have time, so there is one trick that we can perform. And what we can do is we can just multiply the x2 here and x2 numerator and denominator. Then what will happen is this x1 multiplied by x2 multiplied by cos theta is nothing but the dot product between x1 and x2. It's the definition of dot product, right? X1 x2 is nothing but norm x2 norm x1, sorry, norm x1 norm x2 multiplied by cos theta. So I can write this term as this thing, x1 multiplied by x1 dot x2, right? This x2 was there already, so x2, this is vector, right? And divided by mod x2 square. So this will also give you the projection of x1, correct? And why this is useful? Because we don't need to calculate cos theta or anything. We are given x1, we are given x2, 1 2 3 3 2 1. Just put the value here and you got the answer, correct? X1 value distance from origin will be always smaller than x2, right, as per diagram. Where is the origin? Okay, this you are saying is origin.
I mean the starting point, yeah, exactly.
That's fine. Hey, we can have like x2 less than x1 also. There is no problem at all.
Okay.
We can
So,
have this thing
one
also.
more
See,
point.
we can have x1. Sorry for the color. We can have x1 here, and sorry, this is x2, and we can have x1 also. So this would be the projection, right? So we are multiplying this with unit vector, so we will get this direction, correct? So it is also possible. There is no hard and fast rule. This is also called a projection. There is no problem with it, right? Okay. And one more point that was also not covered. I guess you won't find this in running notes. That given two hyperplanes, right? Hyperplanes, lines, plane, anything, right? And there is a problem also here. There is small correction in the notes. Here it should be not equal to. Let's say we have two hyperplane, 2x plus 3y minus 6, and pi 2 I have 4x plus 6y minus 19. So is this two hyperplane? We can have z term also, w term also, 2, 3, 4. How many terms are given? We don't care. So how can we determine if this is parallel or perpendicular like that? So perpendicular, it is really easy. Just take the dot product. 2 multiplied by 4, 8 plus this thing. See, all terms would be positive. 18, 8 and 19 multiplied by 6, whatever it is, both are minus, right? So you will get all the plus term. So it is not equal to 0, definitely. So these two hyperplanes are not perpendicular. So if they are parallel, how can we check? Just take w1 divided by w2, it is 0.5. w2 divided by w2 dash. So this is second term, right? w1 divided by w1 dash, w2 divided by w2 dash, right? So 3 divided by 6, again 0.5. So these all terms would be similar. W1 of first term, so Wi of first hyperplane and Wi of second hyperplane. 2 divided by 4, 3 divided by 6, how many terms we have? And it should not be equal to WD divided by WD, like both this term, W0 actually. Why? Sorry, this is not a problem. I just forgot to mention about this thing, this thing. Let's say I have 12 here. Then what happened? Both hyperplane are similar. I am just multiplying the pi 1 multiplied by 2. So both hyperplane are similar, correct? So let me prove that actually. Try to prove that. If you just multiply something by some constant, you will get the same, exact same line, right? How to remove everything? How to clear everything? Clear all. Don't say. Let's say I have one hyperplane called 2x plus 3y minus 4 equal to 0, like this. And if I take exact double, let's say 4x plus 3 multiplied by 2, 6y minus 8. then what will happen? It will be almost same line. See, both are similar. I am just multiplying by 2. Correct? So this last term should be different. Here it should be, if I take just 5, both are parallel, right? Because 2 by 4 0.5, 3 by 6 0.5. Correct? Then these two things are parallel. Correct? And if you get all this, you can say, what you can, this ratio 2 by 4, 3 by 6, 4 by 8, everything is similar, then they are overlapping each other, right? So there can be a question like if these two hyperplanes are overlapping or not. You just need to take the this ratio 2 divided by 4, 3 divided by 6, 4 divided by 8, if it was a 8 here. And if you want to see like if it is perpendicular or not, just take the this thing, what is this called, dot product, right? So I don't know if I would be able to calculate that. Minus 2x, so this is minus 4, minus 6, and I don't know how what to put it now. Okay, let it be. Right, so let's take a perpendicular line, then it would be easy. Perpendicular, where it is, perpendicular line, right? So it can be anywhere, right? No problem at all. So what is the equation of this line? Minus 1.5x, y equal to minus 1.5x, so y minus 1.5x plus 0.515. So if you take the dot product, 2 multiplied by 1, 3 multiplied by 1.5, minus 4 multiplied by plus 1, 0.15, then you will get the answer 0. So they are perpendicular to each other. Okay, I guess the theory is over. Let's jump on to assignment now. Any questions, guys, till now? Okay, so where are the assignment? Yes, question number 1. What is the distance of a point P? And let me open the solution also. It is available on Drive, guys, from April. Algebra, exercise, visualization, ASN exercise, all this thing. Okay. Can we rotate? Oh, can we rotate here, guys? I don't know how to do it. Let me open locally. Same one, subject 1, algebra, calculus, exercise. Okay, so let's read the question first. What is the distance from the point P to the plane this 2x minus 2y plus 5z equal to 0? So this is just the like they have written this equation twice. Nothing to worry. Fill in your answer to 3 decimal place. Right? Feel free to use a calculator on your phone or online. This won't be a case in exam. Okay. Let me remove rotate clockwise. It would be a mess. Yes. So we have this point P, correct? And we have this hyperplane 2x minus 2y plus 5z equal plus 8 equal to 0. So what is the f of x, or you can say the f of x y z, right? We have 3 dimensions. So it is 2x minus 2y plus 5z equal to 8 plus 8, right? I am just removing this 0, right? I am just writing it in a f of x form, right? So what is w here? So w is nothing but w1, w2, w3. So w1 is 2, w2 minus 2, w3 minus plus 5, correct? So this is my w and this is my p. Point is given 4 minus 4 3. Now it is trivial. How to calculate the distance? Distance is nothing but f of p divided by mod w, norm w. So f of p is nothing but just put 4 minus 4 3 here. So 4 multiplied by 2 minus 4 multiplied by minus 2, 5 divided by 5 multiplied by 3 plus 8. So I got 39. What is mod w? Just don't count 8. We just need to focus on w. So it is under root 2 square, 2 square, 5 square. So under root 33. So the answer would be 39 divided by root 33. Correct? Any questions, guys? We saw this earlier also, so let me move ahead. Algebra took like 1 hour, and we just need yet to finish the assignment. Okay. Angle between, we need to calculate the angle between this and this. We have 2 points and we need to calculate the angle. So how can we do that? Right, so to calculate the angle, as I mentioned earlier, we just need to use the dot product, because there is no other way that you can calculate the angle between these two things. Correct. So a dot b, this is a numpy, you can say, thing. So a dot b is nothing but ab cos theta, mod a mod b cos theta. So what I will do, what is mod a, norm a? 3 square, 4 square, 1 square, under root w1 square, w2 square, w3 square. Similarly, what is mod b, norm b? 2 square, 1 square, 1 square. Right, multiplied by cos theta is nothing but dot product. And how dot product will work? Similar dimension we need to multiply and add it together like this. 3 2 ja 4 minus 1, 4 multiplied by minus 1, minus 1 multiplied by 1. Right, so whatever the answer we get, but I guess we get 1 here. 3 2 ja 6, minus 4, minus 1 minus 5, 6 minus 5 equal to 1. 1 divided by this thing, it would be cos theta. And how can you calculate theta? Theta, you just need to take the cos inverse of this. Correct. And cos inverse by default would have been radian, so I just multiplied by 180 divided by pi, because we were asked to calculate in the degree. But I guess in our calculator we have option to choose between radian and degree. So you just need to calculate 1 divided by under root 26 multiplied by under root 6 and just take the cos inverse. Correct. Okay. Next question, distance of p and pi. Right, and p is nothing but 0 0 0. So what was the question actually? What is the distance from a 3D point p? So this is nothing but the origin to a plane whose equation is this: 2x plus y minus 2z equal to 4. Right, so how can we calculate this? So pi is given, so w is nothing but 2 1 minus 2, w1 w2 minus 2, sorry, w3, and w0 is minus 4. If this 4 will come here, it would be minus 4 equal to 0. So how, what is the value? So it is nothing but w0 divided by mod w, and we need to calculate the distance, right? So no need to consider the minus sign, and actually this distance is defined as minus w0 divided by mod w. But when we are talking about this thing, uh, distance, the sign doesn't matter, right? So minus 4 minus minus plus 4 divided by this thing, 4 divided by under root 3. I'm just not going into calculation, right? You get the idea. Okay. Yes, interesting question. Let's okay, not this one. Okay, both are interesting. Let's be fair. Yes. Given these 8 2D point, it's follow 1 1 2 2 3 3 minus 1 minus 1 minus 2 minus 2 this. Let us draw a circle whose center is at the origin. Right, so we need to draw the circle whose center is at the origin, such that all 8 points are inside or on the circle. Right, either it is on the circle or inside the circle. What is the radius of this circle? Right, fill your answer around it to decimal point. So if we want to take, like, we have some random points, right? We have these coordinates and we have random points like this. Now you want to draw a circle such that all the points are either inside the circle or on the circle. Then what you will do? You will just see, like, which is the farthest point, right? Which is the, like, at high like highest distance. So let's say this is at the highest distance. So now what you will do? You will just take the circle, draw the circle, right? That's how this point would be on the circle and all the points would be inside the circle. So after seeing all this thing, which point is like very much far from the origin? 1 1 is like near, like 2 2 is like more far than 1 1. Then 3 3 minus 1 and 1 1 would be at same distance. 1 1 and minus 1 like this. So 2 2. So the current winner is 3 3. Let's go further. Minus 3 and 3 we would have a tie. Again we have 4 4. So 4 4. The current winner is 4 4, not this one. So 4 4 is the farthest point, right? Farthest point. And minus 4 plus 4. So it would be somewhere here. Minus 4 plus 4. It would be somewhere here, right? So we need to draw the circle with the radius from 0 0 to 4 4. So this should be the radius, right? So we need to consider either this point 4 4 or minus 4 plus 4, right? So what would be the radius then? Radius we can calculate easily, right? 4 minus 0, 4 square, 4 minus 0 square, under root, right? Definitely under root. 4 square 16 plus 16, so under 32 is the answer, right? So under 32 is nothing but 5.66. I guess you got the idea, right? We just need to understand like which point is at the highest distance or the farthest from the origin, right? Because we need to draw the circle which encompass all the points. Any doubt, guys? I guess we have a beautiful diagram also. Algebra notes. I don't know where it is. ASN exercise. No. Exercise 2. It was somewhere uploaded. I guess it was uploaded. So if you put all the points, now then again it would be clear. Algebra exercise visualization. Ah, okay, let it be. Let's jump on to next question. Given two hyperplane, this wx plus b equal to 0 and wx plus c equal to 0. Given c is greater than b, right? C is greater than b. Which of the following represent the distance between two hyperplanes? Parallel hyperplanes, right? So what they are saying is parallel hyperplanes. So these two hyperplanes are parallel. They are giving it, right? Hint, always try to draw a diagram. Okay, we will. So let's say this is origin, and let's draw hyperplane 1 here and one more hyperplane here, right? And these two are parallel, right? So this distance from the origin is defined by w0 divided by mod w. W0 divided by mod w. So w0 is nothing but b given by divided by mod w, and the second hyperplane, the distance would be defined as, this distance would be defined as c divided by mod w. So this is whole distance, huh? Just keep in mind. This is full distance from here to origin, correct? So now what they are asking is what is the distance between two hyperplane. So we need to calculate what is the distance between these two hyperplane. So it is simple, c divided by mod w minus b divided by mod w. So if you take mod w common, it would be c minus b divided by mod w. And why I have taken this c and this b? Because we have given c is greater than b, right? So this is c, this is b, and distance is c divided by mod w, b divided by mod w. The equation I am using, formula I am using is w0 divided by mod w from the origin, because all the term x1 x2 up to xn would be 0 for origin, right? I guess the idea is clear, right, guys? Okay, I will take it as good to go. And yes, this is the, you can say, derivation. What if planes are perpendicular? Distance would be 0. Sorry, the distance between w1 and w2, how to calculate if both are perpendicular? It would be 0, right? Even if they are intersecting, now how can you calculate the distance, perpendicular distance between the two planes? We need to given 2 points on the plane, then we can calculate, and it would be nothing but the Euclidean distance, basically. Okay. Next, I guess we have 9 question or what? 10. Okay. 6. Given to hyperplane, 2x plus 3y minus z. Okay, we have the similar example. Equal to 2, and pi 2 is 4x plus 6y minus 2z equal to 1. Which of the following statement is correct about this plane? This can be MSQ also. Both are parallel to each other, sorry, perpendicular to each other. Both are the same plane. Both of them are the same plane. And what would be the case if both are same? then the ratio between all the terms would be similar, then both are same plane, that means overlapping each other, right? And both are parallel to each other, none of the above. So how can we calculate this? Simple, just take the ratio between each term. If we take the ratio, right, 2 divided by 4, 3 divided by 6, 1 divided by 2, just ignore this thing for a moment, then we can say like this is perpendicular to each other, correct? 2 divided by 4 0.5, 3 divided by 6 0.5, minus 1 divided by minus 2 0.5, and this 2 divided by 1 is 2, it is not 0.5, right? If it was 1 and 2 here, then both plane would be overlapping each other, or both of the plane are same, right? There is no difference because we are just multiplying pi 1 by pi 2, correct? But in this case both are parallel. Why? All the w's are having the same ratio, 2 by 4, 3 by 6, minus 1 by minus 2, but this intercept term, or you can say w0 term, have the different ratio, 2 by 1 is equal to 2. That means both plane are parallel. By the time I was solving this question, I had no idea like how to identify parallel and this perpendicular plane. So what I did is I just go to GeoGebra, draw this plane and answer my question. Kind of a hack. Okay, let's take this next thing. Okay, let's try to solve this using equation, because geometrically it is easy to visualize, but let's try to solve it using this thing, equation. I guess I don't have solution here, but we can solve it using equations also, maths also. Let's try. So what we are given is this is S1 center, and this is center 1, this is center 2, given two hyperspheres, right? We have two hyperspheres, one, and there is one hypersphere S2, S1 and S2. So this hypersphere center is S1, 1, 1, 1, 1, 1, right? So this is in 6D, right? And radius is equal to 1. And we have second hypersphere with the radius equal to 2 and the center is 2, 2, 2, 2, 2. So which of the following statement is true about them? Don't intersect at all, they just touch each other at a one point, or have some region of overlap, right? Or what next? None of the above. I just wasted time. Okay, so how can we determine? Let's take example in today. If two circles are let's say overlapping each other, or let's say are touching at just one point, then what happen is, let me draw one big circle. Then what happen is this is looking like a potato, but what happen is if they are touching at each other, then the distance between two center, if you take the distance between center 1 and center 2, it would be exactly similar as r1 plus r2, right? Yeah, right. R1 plus R2 would be exact same distance of C1, C2. If they are not intersecting each other, let me take another two circles. If they are not intersecting each other, then if the distance between two centers would be greater than summation of R1 R2, this distance R1 and R2, if you take the summation, it would be less than this center distance C1 and C2. And if they are intersecting each other, then what will happen is the distance between C1 and C2 would be less than R1 and R2. R1 is this and R2 is this. So if you take the summation of R1 and R2, then it would be greater than C1 and C2, the distance between two centers, right? So using this thing, by using this, you can say knowledge, let's try to solve this. So the what you can say, the summation of radius 1 and radius 2 is nothing but 3. R1 plus R2 we know 3. So we just need to calculate the distance between S1 and S2. So how to calculate the distance between S1 and S2? 2 minus 1, 2 minus 1, sorry, under root 2 minus 1 square, 1, 2 minus 1 square, 1, under 2 minus 1 square, 1, like this, right? So how many times we have? 6 times. So it would be under root 6. It is nothing but 2.45. Thanks for this. 2.45, and 2.45 is less than 3. So this is the case, right? This is the case. If it was exact 3, that means they are touching each other at single point. If this distance was greater than 3, let's say it was 4, then it has don't intersect at all, right? But here the distance is less than 3, that means the center distance between say like two circle is less than the summation of the radius r1 and r2. That means s1 and s2 have some region of overlap, right? So this is the answer. Any questions, any doubt? Because last three are, I guess, easy one. I don't know, I'm just guessing. Okay, let me move further then. Question number 8. Okay, so we have given a point x, again 6 dimension 1 1 1 1 1, and a hyperplane pi with the normal vector. So w is given 0 0 0 0 0 1, and w0 or bias term b is given -1. Which of the following is true about x and pi? Always try to draw a diagram. How to draw a diagram in 6 dimension, I don't know. X is in the positive half on pi or negative half, or it is like at a distance of 1 unit from pi. So the idea is clear, right? We have given w, we have given w0, we have given x. So how to do it? Just put this point inside the equation of hyperplane. So w1 x1, w2 x2, w3 x3, all would be 0. 1 multiplied by 1, 1 minus, sorry, plus w0. W0 is -1. So the 1 minus 1 would be 0. So what we are getting is f of p is equal to 0. That means it is satisfying the equation of hyperplane. That means it is on the hyperplane itself. Correct? Say this thing. F of p. This the p is given 1 1 1 1 1. W is given 0 0 0 0 1, and w0 is given -1. Right? So wtx plus w0. Right, so if we put 0 0 0 0 1 and take the dot product, we get 1 minus 1 equal to 0, like this. Correct? See, here I have derived and then used. Okay, but this is actually easy question, you can say. Very easy, they have defined. Not this one, 10th one. Okay, so let's take the second last question of a day, baby. X1 is given 1 2 3 4 5 6. X2 is given this thing -1 -2 up to -7. Which of the following operation is valid? See, if you see, this is 6 dimension and this is in 7 dimension, right? -1 to -7, 1 to 6. So which of the four operations is valid? Can you do dot product? No. 1 multiplied by -1, 2 multiplied by -2, 6 multiplied by -6. Then what about this 7? We can't leave it, right? So we cannot take the dot product between 6 dimension point and 7 dimension point, right? So this is not possible. And can you take summation of x1 and x2? You cannot, right? How to take sum? 1 plus -1, 2, 2 minus 2, 3 minus 10. What about -7? So you cannot perform the minus operations also. Plus you cannot operate, you cannot do. Minus also you cannot do. See, this is possible in numpy, but you cannot do it actually. X1 plus 2. So this is scalar entity, right? This is kind of a 1D, right? So you cannot add 2. Where to add 2? 1 plus 2 or 2 plus 2 or 3 plus 2, like that. But in numpy it is possible. If you give x1 plus 2, it will add all to here. So what it is doing is, it is basically taking this 2 as the 6D point, 2 2 2 2 2 2 2, like that, and adding x1 plus 2, like that. But in normal, just forget about numpy. If numpy was not there, this is not possible. So only possible thing is 2 multiplied by x1. Yes, you can multiply it by 2. So we are just scaling our vector by 2. Correct?
Mayur,
Yes.
if we do this D option in NumPy, like x1 plus 2,
Ah.
so what would be the output? Will it add 2 to all of the elements of this vector? Or
Yes. 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 It
Acha.
will add to like all of the elements.
Oh,
I'm
okay.
not 100%, but 99% I'm sure.
Okay, okay.
So yeah, you can check it on GDP or anything. Okay.
Sure.
Now, last question. This can be like in hard question also. If this x1 and x2 is not similar, this much easy, right? Because this is a special case. Why this is special case? Because see, x1 is 1 1 1 1 1 1 like this. So let me take the 2D example first. So if see, this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. So how many points? See, 1 1 would be here, 2 2 would be here, 3 3 would be here, and all would be on the same line, right? X equal to y, right? X equal to y. Now I am giving the vector x1 is 1 1 1 1 1, so 1 1, right? So this is vector 1, and I am having the second vector 2 2 2 2 2, right? So the second vector would be somewhere here. I am just overlapping each other. See, both are overlapping, right? Uh, yes, both are overlapping each other. 2 2 2 2 2. So what would be the resultant vector, right? When we project x1 on x2, so this x1 is projected on x2, so it is already projected on x2. How to project it further, right? It is already on x2. So what would be the projection would be x1 only, right? 1 1 1 1 1. So you can directly mark the answer 1 1 1 1 1. But if we have this would be the, you can say, tough question. If we have different you can say vectors x1 and x2, why it would be difficult? Because if you follow this method now, this is horrible. You first need to do the dot product and calculate the cos theta, then using the formula of this x1 cos theta x2 hat, right? That formula we had for the projection, then you can then you can get this projection 1 1 1 1 1. But we have this formula, just remember this formula: x1 dot product x2 into x2 vector, right? X2 vector we have because projection is vector, divided by mod x2 square. And how we got? We just multiplied x2 on numerator and denominator. Then our life would be easy because we don't care about cos theta anymore. So how we will solve this? X1 dot x2. So 1 multiplied by 2, 1 multiplied by 2. So 2 plus 2 plus 2 plus 2. How many times? 6 times. So 6 to the 12. Right? 12 divided by x2 square. Right? So x2 square is, say, what is mod x2? Under root x1 square, x2 square, x3, so like this. And if I take square, the under root will cancel out. So it is 2 square, 2 square, 2 square, 2 square, 6 times. So it is nothing but 4 plus 4 plus 4. It is nothing but 4 multiplied by 6, 24. And x2 is nothing but vector, so just write the x2 as it is, 2 2 2 2 2. So we have 12 divided by 24, 2 2 2 2 2. So 12 divided by 24 is 1 half, so 1 half of 2 is 1 1 1 1 1. So we got this answer. Geometrically it is really easy, but let's take one more example, then you will appreciate this. I got this really good tool, but the question was from this article. We have this question, like, let's say in the exam. Now the notation, like how you remember the thing, would really come into picture. Because in exam it happens like you forgot about what was x1 upon x2, x2 on x1, like that. So what we are given is, what is the vector projection of s onto r? So what we need to calculate is projection of s onto r, right? So now how you write the equation? So we are projecting onto r, so we need to take the direction of r. That means r vector we need to take, and and in denominator we have mod r, but we know the formula, we are taking the square. So mod r square, and here we have dot product between two vectors. So dot product can be r dot s or s dot r, both are similar, correct? So s dot r, or you can say r dot s. So this is dot product. So now we know, if you want to calculate, so s dot r is nothing but 10 multiplied by 3, 30, plus 5 multiplied by 4 minus 20. So it is nothing but 10, because last one term is 0. Divided by mod r square. So mod r square, 3 square, 9, 4 square, 16, 25, under root 5, 5 square is 25. Right? And now r vector is given 3 minus 4, 0. So the answer would be 5 to the 6 divided by 5 minus 8 divided by 5, right? 2 by 5, if I multiplied, it would be 6 divided by 5 and minus 8 divided by 5 and 0 already. Alright. So this is the answer. So let's verify if it is correct or not, right? Because it would be a really hectic exercise to calculate the theta first, then use that s cos theta r divided by mod r. So if I put this thing 10, 5 minus 6, 3 minus 4, 0, then we get the similar answer. How they calculated? Similar way, right? 10 divided by 25, 3 minus 4, 0, 6 by 5 minus 8 by 5, 0. The same answer we got. The Vidya Balan is not happy. Shakuntala Devi, okay. So this is the answer. And see, remember this formula actually. And see, this formula is vectorized formula. So if you want to calculate the vector, then it is nothing but AB divided by B square B. This same is like x1, x2, x2 vector divided by mode of x2 square. And this formula is nothing but the norm of projection. That means what is the length of a projection? If they ask what is the length of a projection, so this is called the vector projection and this is called the scalar projection. Right? There is a term actually, vector and scalar projection. It is written like that. Scalar projection versus vector projection. So what we have calculated is vector projection, and scalar projection would be nothing but under root 6 by 5 square plus 8 by 5 square. And you can say shortcut would be just remove this r from here as s into r divided by r. So what we are doing is we are just removing the direction. So r divided by mod r is the direction, so we are removing it. So the scalar projection would be defined like this: dot product as it is. We are removing this r divided by r, so one r is gone. So we have one remaining r, mod of r. So this is called the scalar projection. Scalar. I'm not writing it because it hurts with mouse. Okay. And why I'm discussing this is because we had this out of syllabus question, I guess. See this one: given vector v1 and v2 of same dimensionality, what is the length of the projection? Length of the projection is nothing but scalar projection, and they have written here scalar projection and vector projection. So it is v1 v2 divided by mod v2, v1 v2 divided by mod v2, right? So we are done with algebra. Calculus is remaining and it's 11 already. So your call, guys. Do you want to finish the theory today and assignment tomorrow, or we should take the calculus tomorrow only?
Mayur, we can take at least theory part quickly.
Okay.
I mean, if others are also agreeing.
Uh-huh. I am never out of energy, so I am just asking.
And we are recording this session as well, right?
Uh-huh.
We are recording this, right?
Yes, we are recording
Yeah.
because see, this is going to take like much time today. Like, and I am assuming like we would need at least 2.5 hour of session when we start this O notation and everything, big O and everything,
Yeah.
complexity and recursion. These examples, recursion example that solving those equations that we got from Khalil sir's assignment. So
Correct.
definitely, like we would need like 2 hours is minimum. Above 2 hours is your call. Average energy level of 32 people.
Are we going to discuss that programs also in the first subject?
Which programs?
The coding part. There
I
was some
guess
coding needed also.
we should not because I am not good at teaching code. I can't explain
Okay.
code actually.
Cool.
So I we will definitely see. That's why I have put this Python for data science introduction as 26th. So this is kind of a self study, inbuilt data structure, if while group do and everything. Correct. So the our goal today's goal is nothing but to if we can finish the calculus, then tomorrow we will be introducing this formulas, this time and space complexity, right? So if you don't get time tomorrow, I will skip the theory part. We will directly jump on to numericals tomorrow, right? So let's see calculus. Let's take like 3 or 4 minutes break, then we can continue, right? Get refreshed, guys, because uh, It's hard to actually this concentrate. Meanwhile, let me open the calculus notes. I hope they are not following the trend same as these exams, this mid exam in semester exam, like asking like from another planet actually. Oh, open no.
So Mayur, this is your blog, right?
Yes.
Okay, okay. Yeah, yeah.
It was like taking much time. So then I moved to Journal Plus Plus. Then what I did is completely engineer hack, lazy person hack. I just took the this thing. That's why it's taking time. I just embedded the PDF actually.
Acha, okay.
Then I found the really good solution. Then no one will realize. I just embedded the images without background. Sorry, with
Okay.
background. So images. So this will look like a notes on a block
Mm-hmm.
like this. Because it takes time, right? Writing the equation in latex basically. So this is latex form of equation. And just a fun fact, like all the books are written in latex, mostly.
And this is similar to like we do that in Confluence, like in Office.
In Microsoft Office, if you will
No,
try
not
to
Office,
copy this,
Confluence, like Atlassian
okay,
tool set,
Confluence,
Confluence
okay,
and all those.
yes, yes, I
We
have no
use
idea,
those.
but yes, yes. Because in book, like we need to use so many of these things, lambda and alpha and some Greek parameters, these equations. In Word, it would be a like hectic to write this equation in Microsoft Word. But once you know latex, now you can like write this like quickly. फटाफट फटाफट हो जाते हैं फिर तो. Okay. Theory part is easy actually in calculus. Just the intuition part is, you can say, tough. Okay. Yes. So let's. What are the topics actually we have? So it is nothing but the limits, range, domain of popular functions. Basically, yes. Tangent and secant. Now it will make more sense because we have used e to the power x much, mod x much, right? Length, or sorry, not length, but natural logarithmic. 1 by x, I don't know. X square we have used. So this will make more sense actually. Derivations of, sorry, this is derivation, huh? Differentiation, meaning and what is the geometric intuition, cool. Continuity and differentiability of a function, important topic. Rules of differentiation, derivation of popular function, what is sine, cos, tan, like that. Partial differentiation, del part we have, which is used in gradient descent. And optima of a function, where if we have single variable, multivariable, minima, maxima, like that. And we will try to define the regression problem and solve using the calculus. And this is same as what we have done in the linear regression, if you remember, right? Okay, so let's start popular function. And if you think intuitively, now it makes definite sense. If there are points like this, and if you want to fit a line, it is linear regression. If there are points, and if you want to separate them using a line, it is logistic regression, right? So both are line, both are doing different thing. Both we are using gradient descent to arrive at the w and b. So both are using w and b, but the method in linear regression and logistic regression is completely different, right? Both are kind of a line fitting, correct? One is doing classification, one is doing regression. So it's really beautiful. Okay, now let's jump on to domain and range of a function. So what is domain? Domain is nothing but you can say area, right? If there is a DOM, there is defined area when it is defined, right? So domain is like where given function is defined. If you go out of a domain, function is not you can say defined, right? You don't know like what is the value of function, or you can say infinity. Infinity is nothing but not a what you can say function is not defined at that point, correct? And there is one more intuition to check if function is defined at that point or not, right? The differentiability and continuity that is used by limits. And what is the meaning of limit? Limit is when you move towards 0 and 0. So limit x to the power x tends to 0. There is one problem, I guess, here in this diagram that Vinit said in first subject and not corrected, I guess. Let's find if we can find out. So limit is nothing but you are coming from positive direction towards 0, right? You are not taking the value exact 0, you are coming from positive direction towards 0. So it is defined as limit x to the x tends to 0 positive, right? Like that. And uh, okay, now it's clear. And negative limit, so it is nothing but the left hand side limit, right? So, and x tends to 0, we are coming all like coming towards 0, but not exactly 0 from the negative direction. So it's called this thing, right? And this both should be, if both are 0, both are similar basically, then the function is defined there, correct? We will see it again in differentiability. So what is domain? Domain is nothing but as an input how many value you can give to this function. So function is x square, you can give any value, right? If you can, and just check for 0, minus infinity, plus infinity, you will know the domain. And some negative value, positive value, of course, right? So if you give a negative value, it will give you some output. If you give positive value, it will give some output. And always it will give the positive output, right? Either it will give 0 or the positive value. Minus 2, output will be 4. Plus 2, output will be 4, correct? So the range is nothing but r0 plus all the real value, all the positive real value with 0, correct? And the domain is r, you can give any damn value on the x-axis, correct? Now let's take the another function 1 divided by x, correct? And we don't need this graph actually. See, you can give any value. No, we can't give 0, right? If you give 0, 1 by 0 would be infinity. So the domain would be r minus 0. You can give any value other than 0. That means r minus set 0. R is nothing but the set, real value set, correct? And what would be the output, right? So the output would be again r minus 0. When this would be 0? When x equal to infinity, then and only this would be 0, correct? So it cannot give me the output 0, because when and only x is infinity, then we have 0, and there is nothing like infinity, correct? So 1 by infinity, then and only we can get the 0. So the domain and range of 1 by x is same, r minus 0, correct? And it is not differentiable at 0, because if you see, if you come to from the this positive side, 1 by 2 is 0.5, 1 by 0.5 is 2, 1 by 0.00001 is 1000. So if you are coming from positive side and value is decreasing and decreasing going towards 0, it will tend to be plus infinity, right? So it is plus infinity. And if you are coming from this 1 divided by minus 0.0001, it would be minus 10,000. So I am getting more and more higher and higher negative value. So when you tends to be 0, right? When you touch the 0, it would be minus infinity, correct? So this value and this value are different. If you are coming from positive direction, you will go up direction, plus infinity. If you are coming from this direction, it will be minus infinity, correct? So it is not differentiable at this point, and it is also not defined at this point. 1 by 0 is infinity, plus or minus, I don't know, correct? Okay, let's take log. Like if you take log base 10, log base e, log base 2, the graph would be almost similar. It would be like there would be a minor difference, right? And the graph would be something like this, correct? So if you are coming from positive infinity, so sorry, positive side towards 0, then log 0 would be minus infinity. It will it will fall after 1. Log 1 is 0, right? So it will be negative if the value is less than 1. So how many values you can give? You can give only the positive value, right? For negative value, log is not defined at all. So what is the domain, right? What is the area of this domain? It is r plus, right? And how many value, how much value it can give? So it can give any positive value, because after one it is positive, before one it is negative. So the value would be r, not r0, because it is 0 only and only when it is infinity, right? Because when sorry, it is not getting the value 0, right, at all. Sorry, log 1 is 0, so the output is r, so we are getting 0 plus and minus everything, so it is r. Sorry for the mistake, right? E to the power x, it is looking something like this beautiful curve. It is always positive whatever the value you give, right? So and yes, when it would be 0, right? The answer is the question is when it would be 0. So see, first let's talk about domain, right? So domain is how like which value you can give as input. You can give any value, right? Any positive or negative value. E to the power x is defined. But and what is the range? Range is how many value it can give, right? So when you go towards like minus infinity, when you are going towards minus infinity, it will be 0. And if you are going towards plus infinity, it would be infinity plus infinity, right? Not infinity plus infinity, correct? So it is not 0, right? It is taking all the value, positive value, all the positive value, and it is taking negative value as well or not. The y is always positive, right? So it is r plus minus 0. See, there is a mistake here. See, it is taking any negative value. No, you can't have negative value, right? If you gave x is equal to minus 4, so it is nothing but 1 divided by e to the power 4. So it is also positive. It's very small value, but also positive. So it is r plus minus 0. So the range would be r plus minus 0, because it can't be 0, correct? So there was a mistake here. I guess Vinith at that time found out. Okay, let me remove the last but not least, mode x. Mode x is defined, it's having this v kind of a shape, right? So if you are coming so what is the domain? You can give any value, right? Plus 1, minus, or 0. It will give you all the positive value. If you give 0, it will give you 0. So it is all the positive value plus 0, r0 plus no negative value, right? Because we are taking the mode, so negative would be positive, correct? Okay. So one concept about tangent and secant. So okay, I am just keeping it. Tangent is nothing but the line which is touching at exact one point, and secant is nothing but which is intersecting a function at multiple point. It is called the secant, correct? And tangent is always, say, if you decrease this distance x2 minus x1, right? Then this line will see, this distance will be reduced, and this line will touch at just one point, right? Then it would be called secant, sorry, tangent, correct? And why it is called tangent? Because when if you take the tangent, when if you have any function like this, and if you take the tangent, this is tangent, right, touching at one point, just assume. And if you take this theta, then the slope, so the slope of the point, slope of this function f at a given point x is defined as tan theta, and it is nothing but your differentiation dy by dx at tangent. So tangent is nothing but saying, if the see, the tangent has really beautiful values with respect to f, right? So dy by dx is nothing but tan theta, tan theta equal to, okay. Now this tangent has really good properties, right? So if I take simple x square, this is x square, right? If I take simple x square and some point here, some point here, and some point here, then what will happen? If I take tangent here now, the theta, see, tangent would be something like this. The theta is positive, That means my function is increasing. See, 2, 9, 16, 25, 64, like this. And if the tangent, see, if tangent, this theta is more than 90, so the tan theta would be negative, right? After 90, tan theta is negative. So this tangent, or you can say this tangent divided by dx is negative. That means your function is decreasing. Minus 36, minus 25, minus 16, minus 9, like that. Correct? I said a gem file with the meeting. Okay. And if I take like at this point 0, the tangent would be 0, theta is 0. That means your function is not decreasing, not increasing. That means your function is optimum here. It can be, you can say, minima or maxima, right? If you take minus x where it would look something like this. So it is increasing here, it is decreasing here. So your theta, if you take the tangent here, the theta is nothing but tan theta is positive. That means your dy by dx differentiation is positive here. Here it is also positive, here also positive, here it would be 0, then it will be negative all here, right? So this differentiation, the first differentiation, has a really nice property, correct? When the function is increasing, it would be positive at optima or saddle point. Sad, it is very sad that we have saddle point, that's why it's called saddle point. It would be 0, and at negative, if the function is decreasing, it would be negative, first differentiation, right? Okay, so derivation, differentiation, I'm just not going into this thing. We just show this. If it is greater than 0, function is increasing, less than 0, decreasing, 0, that means optimum. If it is not defined, f is not smooth or not defined at x, right? If f dash x is not defined. Now what we will check, what is the differentiability, right? So this can be a really good candidate to make the MCQ. So function is continuous at point A if satisfied below two condition, right? Now using geometry you can define, but given a very, you can say, tough equation, or which you cannot draw on a paper, then how to do it, right? So given a function, let's say I have a function f of x is equal to 1 by x. Now we have two things. See, the function is called continuous if satisfied to this condition. If it is differentiable, it should define this condition, f dash a. So this is the formula of differentiation: x plus dx minus f of x divided by d of x, right? And see, if it is not continuous, then most of the time it is not differentiable at all, right? So let's take function 1 by x. Now what they are saying is it should satisfy two conditions, and let's say I am saying if it is continuous at 0 or not, or if it is continuous at 1 or not, right? So the first condition, f of a is defined, f of a. So if I put 0, 1 upon 0 is not defined, right? So it is not continuous at 0. First condition does not matter, right? So we don't need to check for this second condition at all, right? Next condition, let's take 1. Now what will happen? F of 1. So 1 divided by 1 is 1. Okay, so first condition is met, satisfied. Second condition, limit x to the x to 1. So what they are saying is, if I take 1 upon x, if I coming from the positive side or negative side, it should be 1 only, right? So if you are coming from positive side or negative side, it is already 1, right? 1 upon x, if you are coming 1 upon x, if you draw, it would be something like this. So if you are coming from this side or this side, it is 1 only, right? Because there is no break. But at 0, what happen is it looks something like this. So at 0 there is a break. If you are coming from here, you are going upward. If you are coming from here, you are going downward, right? So this limit is also true. So it is continuous at 1 but not at 0. And what is the differentiability rule? So it is similar as we need to calculate limit dx tends to 0. And whenever there is no sign plus or minus, that means this limit should have the similar value. If I take 0 plus or 0 minus, from any direction I come, it should be the same answer, right? So the function is differentiable at point A if f dash a is defined. So we need to calculate f dash a, then and only we can say. And most of the time, if the function is continuous or is not changing rapidly, then most of the time it is differentiable. Not always, most of the time, right? So let's take one example, mod x, right? So mod x, if you take x equal to 0, it is defined f of 0 is equal to 0, and it is also, you can say, continuous because there is no breakage. It is v like shape, like this. So it is continuous, right? It is defined and continuous at 0, but it is not differentiable at x 0. So dx by dx is not differentiable. Why? Because it is rapidly changing. It should be always smooth. And one geometric intuition I would like to give is, you cannot draw a single tangent here, right? I can draw tangent like this. I can draw tangent like this. I can draw tangent like this, something like this, right? That's why it is not differentiable at x equal to 0. And if you want to prove it, it is really easy. Just put this mod x, just replace x with mod x. Mod x plus mod dx minus f of mod x, like that. Correct? And this derivation is also given in the lecture video, but I guess it's not useful. Correct? But this condition you should remember because this can be MSQ, right? Okay. Rules of differentiation. Uh, I guess we should skip it because we all know, right? If it's summation, f plus d dash, f dash g dash. If it is, if you have product, sine, let's say, x into sine x, then just take the differentiation of first, keep second as it is. Take the differentiation of first one, take the second one, and take the first one as it is, like that. Quotient rule is defined like this. If you have f by g, let's take one example so it is clear. Let's say we have x divided by sin x. Then how you define the first differentiation, right? Derivation d by dx of this or dash. So we need to take the square of the denominator as it is. So it is sin square x, and put the denominator as it is, sin x. Take the differentiation of numerator x. What is the differentiation of x? 1. Minus, there is minus term, so you cannot write like interchangeably. You need to take the differentiation of numerator first, right? Then minus, what is the differentiation? Cos x, and put the x as it is, cos x multiplied by x, like this. Correct? So this is the, you can say, quotient rule, or you can say division rule. Chain rule, I guess we are, okay, chain rule we use very much. So the chain rule, in equation it is horrible, but in practice it is easy. Let's say I have sine of x square, so if it is nothing but f of g of x, like this, right? And I now need to take the d by dx. Now how can I do that? There are two methods. You can go from outside to inside, or you can start from the innermost function, then come like one step at a time to the like outer side. So let's and my favorite is like go from outer to inner. So what function I have? Sine of x square. Just assume this x square is nothing but y. So what is the differentiation of sine y? Cos y, right? So cos, and y is nothing but x square. Then take the differentiation of y, dy. So y is nothing but x square. So what is the differentiation of x square? It is nothing but 2x, right? Or you can do like other way also. Just take the innermost function x square. So the differentiation would be 2x. I guess you can do it like this. Just go like one step outer. So sine of x square, right? So x square is nothing but y. So sine what would be the differentiation? Cos x square, like this, right? And we can have like terrible thing also, sine of log of length ln of 1 by x square, like this. Correct? So it is also possible. Just take the differentiation of 1 by x square, multiplied by ln of 1 by x square, then take the multiplication, then take the differentiation of sine of all this thing, right? So it is also possible. Just do it like in a clean, you can say, handwriting, because there is a chance to miss something, correct? I'm not taking that example. It is 11:20 already. And derivation of some popular function, constant is 1, 0, x is 1, like this. Log is 1 by x, yes. Partial differentiation. Why partial differentiation is useful? Because in reality, we don't have just one variable, right? We have more than one variable in most of the cases, right? So the partial differentiation is nothing but we are doing partiality. How partiality? Let's say I'm having one function. Don't use this term in interview or anywhere. I'm just using it for the explanation. Let's say I'm having this term, having this function f equal to x square y square. F of xy is equal to x square y square. Now I need to calculate the partial differentiation with respect to x. So it is also represented as fx or del f by del x, or I guess it is also represented as like this also. These are three form where whatever you like you can use, right? So the partial differentiation with respect to x is defined as, we would do the partiality. We would, how we will do partiality? We would take y square as constant. It is not constant, but we are doing partiality. So y square is constant, so constant as it is, and differentiation of x square 2x. So 2 y square x, like this, right? And similarly, if I need to do f of y, then we will do partiality. We will just take differentiation of y square. X square is constant. So x square, what is the differentiation of y square? 2y, right? 2y, or I can write 2x square y. Correct? Like this. So this is called the partial differentiation. Keep the all remaining variable as constant. Treat all the variable as the constant and just take the differentiation with respect to given variable. If it is x, take the differentiation of x, keep everything as constant, do the partiality without any problem, because it is partial differentiation, right? Yeah, another example that you can refer to it. And optima of a function, okay, this is beautiful. I would like to show one picture here. Algebra calculus notes. This one. Sorry, this one. Calculus notes. Yes. Decreasing, increasing. I just want to optima of a function. Yes, this thing. See, now what happen is, if you have this kind of a function, right? If it is increasing, see, it is increasing, right, with respect to y. So the differentiation would be plus, positive first differentiation. If it is 0, then it can be either positive or, sorry, either maxima or minima, right? So either minima or maxima, that means it is optima. In other words, is optimum. It can be maximum or it can be minimum. How to derive that? We will say it. If, say, again it would be minus 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 minus, the differentiation would be negative. Then again here it would be 0, then positive, then 0, then negative, right? So where were we? Yes. So how to define if it is optima or not? So first, just take the differentiation, right? Dy by dx. If it is positive, that means it's not optima. If it is negative, it's not optima. If it is equal to 0, that means it is optima, right? We don't know. We just get 0 where I am. It can be maximum or minimum. How to define that? To define that, we use the second derivative. We just take the first derivative, then again take the differentiation, second derivative. If differentiation is less than 0, that means it's maxima. If it is greater than 0, then it is minima. It's opposite way. And if it is 0, it cannot be determined, right? we just need more mathematical tools here. And literally it is written like that, we need more evidence, or we need more calculation to define, right? Why it is so? Why it is this thing? Because if you see, the differentiation was first increasing. In case of maxima, first it was increasing because we were going upward to the hill, then suddenly we fall, right? So we are going downward, so it is maxima, right? This is the hill of hilltop, right? So, and what is this plus 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 minus minus minus? It's the first derivative, keep in mind, right? Dy by dx, f dash x, right? So what f dash x is doing at maxima, at next point it is decreasing, right? At next point it is decreasing because it was first increasing. Once we reach maxima, at the second point it is decreasing, minus minus minus. And how to determine if it is decreasing or increasing? It is nothing but the f double dash x, right? So the second derivative defined like how the your f dash x is changing, and f dash x is defining how your x is changing, correct? So let's take one more example for minima. Let's come here. So first it was decreasing, minus 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 minus. At minima it was 0. Then at next point, what f dash x is doing? It is increasing, right? It is coming to valley. Now it is again climbing to top. So now again it is plus. So how can we define it is plus or not? Just take the second derivative. So f double dash x is plus, greater than that it is minima, right? And if it is negative, that means your f dash x is decreasing, that it is maxima. That's why we have this opposite relationship between f double dash and maxima minima, correct? I guess you got the intuition. Okay, I have written it here also, and I have written the blog also about this. Taken the example and try to solve this, all the values of f dash, f double dash, like that. Okay, I guess this was the last part of our theory. This is out of syllabus. This multivariable function. If you have more than one variable, then how can we define the minima and maxima? So it is simple. We just evaluate to up to point 1. After that we don't need this because we are using the gradient descent, because it is really tough in case of second degree polynomial, third degree polynomial, sorry, second dimension, third dimension, like that. Because in second dimension you can see, like, see how many things we need to calculate. Given f of x y, we need to calculate the partial differentiation with respect to x, respect to y. Both should be equal to 0, so we need to solve these two equation. Whatever the values we get, answer we get every pair, we need to calculate this d parameter, fxx. So second derivative of x, second derivative of y, second derivative of y respect to x, or x respect to y, or y respect to x, both are similar. Then based on d we need to again calculate this thing. So just ignore this for a moment, because we will use very really good thing called gradient descent. This is saddle point, gradient descent, to solve this thing, to find this minimum maxima, right? Minimization problem or maximization problem can be solved using gradient descent. Gradient descent flavor which we are learning is to find the minima. There are other flavors which can find the maximum, but gradient descent is used with the loss minimization. If you have observed, in logistic regression or linear regression or anything, we are using gradient descent for the loss minimization. That means loss equal to 0 or nearly equal to 0, right? The saddle point is nothing but your both differentiation fxx, fyy are 0, but it is not minima or not maxima. Because if you see from this direction, it is like a minima for x direction and maxima for y direction. So this is kind of a saddle point. After that it is also increasing and x is also decreasing, right? So this point is nor maxima nor minima, it is saddle point, sorry, right? Okay. The last topic of a day, last theory topic. Then tomorrow we will start with the numerical. So what gradient descent is and descent is not descent is and how this formula works. Just take the intuition because intuition is very much useful. Uh, Let me try to see. We have this kind of a function, our favorite, this quadratic function. Now, what is happening is, say this is minima that we want to find out, right? Delta equal to 0, right? And on this left hand side, all my derivative differentiation would be minus. The del is nothing but differentiation, huh? So this del would be minus because it is decreasing. On the right hand side, it would be positive. Now, how my gradient descent is defined is what I will do. I will take any random point x1, x2, x2, anything, right? I can take this point also, or it can be here also. There is no problem at all if this is the curve. It can be near to 0 also, or very far from 0 also, here also, or even outside my screen, right? You can take any random point. Now, what will happen is you will apply this formula. Is it visible, this formula? Uh, yes, I can see my screen. So, what this formula is saying is x2 new, the next point is defined as uh, this old point, any random point that we have guessed, plus, or you can say minus, lambda multiplied by del, right? So we are taking the negative derivative. So it is defined like this, right? Now what will happen is, let's say our point was here, somewhere here, right? So the differentiation derivative would be negative. Differentiation is negative, the del is negative. So negative would be positive. So my new x2 would be old x2 plus some positive value. X2 old plus some positive value, 3, 4, 5, anything. So if my x is here, right? If my x is here and I'm adding something, I'm going towards this direction, right? Because this is positive direction, right? If this is let's say minus 10 and if I'm adding plus 5, I'm coming here minus 5, right? So I will come here. So I can take any value in this direction and use this formula, and I will go towards the minima. Yes or no? Yes. And so this is true. This equation is working for any negative, any point on the left hand side, right? If the value is very high, like very out of my screen, even let's say I assume it is minus 1000, then what will happen? My derivation, the differentiation will be also have the high value. So I will take the big step and I will come towards this 0, right? Now let's take like we I say like it should be any random value, right? So it could be in this direction also, in right hand side also, right? Now what will happen is, if I take like x1 equal to ab, this x1 is I took, right? Now what happen is, my del or differentiation is positive here, right? So differentiation is positive. Positive multiplied by negative is negative, multiplied by lambda. Lambda is learning rate. So multiplied by lambda, this is also positive, huh? Lambda is always positive, learning rate cannot be negative. So this is some negative value. So my new point, this new point would be my previous point, let's say 15 minus something x2 old minus lambda multiplied by delta, right? Minus delta, and delta is positive, so this value is negative. So 15 minus 5 would be 10. So 10 would be on which side? Left hand side or right hand side? Left hand side, right? So 10 would be somewhere here. So and this direction is also towards my minima. So gradient descent is really beautiful technique which is using the, you can say, a property of first differentiation, first derivation, and solving this minimization problem, right? And this is true for each and every function in the universe, because the del would be positive if it is increasing. So we are taking back down, because if it is increasing, we are pulling the lag, right? Kind of a lag with this negative sign. And if it is decreasing, then we are welcoming it by the negative sign. Negative negative would be positive, so we are welcoming it towards the minima, right? So it is true for each and every case. Hi, this can solve the saddle point. Saddle point is always a sad point, so you will get everything equal to 0, dy by dx 0, dz by dx 0. But your function would be not minima, not maxima, right? And I guess it was discussed in some of one of the live session that there are some you can say checks in libraries which is checking if it is a saddle point or not, correct? Because in mathematics there are some formulas, or you can say methods, which can check if it is saddle point or not. So gradient descent cannot work for saddle point because your differentiation would be 0 right here at saddle point also, right? So gradient descent cannot work for saddle point. There is a actually question in the chat, right? So this is gradient descent actually. And for regression, I guess we don't need to talk much about it because we solve this linear regression in subject 3. And using this gradient descent, we can solve this thing. And it would be great if you want to increase the Python, you can say, if you want to revise all the concept in Python and coding, and at the same time if you want to learn gradient descent and linear regression, then keep it as a challenge. Just take the random points, generate using np random, which have the linear you can say relationship, correct? And or you can take it randomly, you can write it on your own and try to fit a line. Take the any random w at the starting of a program. It should ask for a random w. I can give 1 lakh 1 lakh, right? 1 crore 1 crore. But after using this gradient descent formula, lambda this, it should be able to find out this line, fitting line, right? The linear regression line, this line, which minimize the error, the square error, right? I'm not going into this because I guess in MCQ or MSQ format, uh, this should not be the important thing with respect to exam only, right? But in linear regression, we derive this equation only. In linear regression, also in that example that's given gradient boosting, that what was that pseudo residual, right? There we also derived this, so I'm not going to derive it again. I guess we are fine, right? It's already 11:37, correct? Any questions, guys, in calculus? It was really smooth. I was expecting at least 5 doubts. Any questions, or everyone is sleeping? Vinith is saying good night by saying thanks, Mayur. Okay, Vinith, good night.
It's clear, Mayur. Yeah. Thanks for
Sure,
your
sure. And if you have any doubt, feel free to ask. No problem at all. Because this calculus is easy when it's equations, but in intuition, it is tough to get. Actually.
Yeah, right.
Sure.